Welcome, everyone. We are going to talk today about scalar fields, and this is a new functionality that is currently in the beta version within DataGraph, and it's something that you can go ahead and download the beta now. Anyone who's a licensed user, even if you're a trial user, you can use the beta and you can try this out for yourself. So feel free to follow along with what we're doing today. We're going to start with some really simple examples, and then we have a couple of more advanced examples that are fun and I think are just really a neat thing to do. So hopefully everyone knows where to get the beta. David, maybe you want to post a link on the chat just so that everyone does know where to get that. But if you go to our downloads page on our website, there's a link to the beta version there. And here we have my new DataGraph file. And if you go under the command menu, that's where we have commands available that are in the beta version. And they're down at the bottom here. There's actually two. There's a freehand command and the scalar fields command. I'll go ahead and say add scalar field, and that adds that to my command list. And what you'll see is that there's a place to specify values and a place to specify X and Y. The data format for using the scalar field is very flexible. So this is one format that you can use, but if you notice over here, there's a layout menu that has all these different formats available. So let me just start with, again, a very simple example. I'm going to go ahead and, well, actually I wanted to just type this in. So I'll click Command 1 3 times to create 3 columns. And this will be my X column, my Y column, and my Z column. And if I just typed in some numbers, because we want to have a grid here, and just create, again, a really simple grid. So I'm doing just 1, 2, 3s, and just repeating. So I have every combination of X and Y between 1 and 3. And then for my Z coordinate, actually for this, I think I'll just use a random number generator for the moment. So we can use an expression field and do a random number. Here I'll just do something from 1 to 10 and create this, and this will be my Z coordinate. So to add these or to select these, I can just go ahead and drag these over here. Here's my X, my Y, and again, my Z, and the scalar field is automatically created. If you go into the detail of this, you'll see that there are a number of these sections that we have for different things that you would want to do with the scalar field. This is slightly different than maybe the way some of the other commands are set up, in that we don't always have these separate sections. But I think for this is a really nice way to go. You can go into each of these and expand them. And then, for example, make this color. So that looks a little bit more interesting. And because the idea here is that you may want to turn on and off different aspects of the scalar field that you're looking at. So I can, for example, add a grid. Now here's just pretty simple. I don't know how well you can see this. I'll increase the size. So you can see this very simple grid. Maybe I want to see the grid momentarily, but then I can go ahead and hide it very easily. Same thing for values. I can go ahead and in this section, I can turn on to see the values. Again, let me increase the font there so that hopefully you can see this. So now I see every number that's actually being represented by the color that's here. And again, can turn that off. There's also contouring options. It's not going to be that interesting for this data, so I'll go over that with a different data set. But let me go ahead and make this maybe, let's do something a little bit different here. So right now I just have a random number. Again, if I change this, you'll see differences in the grid. But maybe I want to make this a function of either of X and Y. So if I said that my grid is going to be the row number times X, for example, then I can get something that's a little bit more interesting. Or I could just say, if I had a function that's 2 times X, then I'm going to get straight lines because everything is just a function of X. I can also then just add something to, I'll do Y divided by 2. And now I have a function that's X and Y. And again, I'm getting these different colors. So there's a number of different color ramps that are built in to the scalar field command that you can select from. You can also create a color ramp variable. You do that over here on the left-hand side where there's the other drop-down menu. There's a color ramp option. I'm not going to go into that right now, but just so that you're aware that that's something that you can do. And let's see what else I want. So let me show you now something a little bit, make this a little more complicated. Hopefully you followed along so far. Because this can handle obviously a lot more data than a simple grid that you have here. So one of the things that the scalar field command can do is to create the grid for you. I believe I've shown this actually in some other webinars where you can use expressions to create longer lists instead of the way I here just typed in my X's and my Y's. So you can do an expression, but this is actually a really handy way to create an XY grid with the scalar field itself. I'll do this by adding a new graph. Again, go under the command menu, add a scalar field. And what I'm going to do here is, instead of specifying my X and Y values, I'm going to change this option for the layout to uniform row, for example. And you'll notice when you change the layout that you'll also get different options for what the grid is. So here, for example, this is saying the origin is 0, 0. By default, it's a 100 by 100 grid. And there's a step size that's given that I can change the step size, for example, to 0.1. And then if you go over to your gear menu on the right-hand side, I can extract the X location as a column, and I can extract the Y location. So we now have this scalar field command that's set up for a particular grid, and I've extracted my X and Y location. And just again, to show you something a little bit more interesting, I'll use the same expression I did over here to calculate the Z value. To do that, first I'm going to group my first set of data. So I highlighted my columns, click the group icon. So here's my kind of simple set. Oops. And then the next set of data, I'll add this into its own group. Let's also just go ahead and, since I already have an equation set up for the variable called X and Y, variables X and Y, then here's my larger grid. Then I can just go ahead and take this expression field I've already created and option drag it down into this new group, and it will go ahead and do all those calculations for me. And instead of, again, reinventing the wheel by adding a new scalar field, I can go back to the one I've already created, click on this object, drag it into this new thumbnail. I think I talked about this before. This is one of my favorite new things to be able to do, to drag between. Though actually, I guess with commands, you've been able to do that for a while. But in any case, so here I have the scalar field command based on the simple data set, the X, Y, and Z. And now I can update this to use the X, Y, and Z from my larger grid by just dragging and dropping this group right onto the scalar field command. So if you didn't know that you could do that, let me do that one more time. So I did Command Z. So I have these two groups here. a simple group with an X, Y, and Z that's currently being used to draw this data. I want to replace this with a group that has the same exact 3 columns named here. So I can take the group itself is a draggable object, and I can drag that and drop it right onto this command. And what that does is replaces every menu selector that has the same name, a column with the same name, with the column in the new group. So I hope that makes sense. I see there are some messages on the chat, and I don't know if I'll go ahead and see what we have for questions. Okay, so a couple of things. Oh, it looks like we got a couple of things answered. There is the question about can you produce ISO contours? Yes, we can do that. And well, I'll show you that in the Volcano example because it's a little bit more interesting than this one. So here, maybe there's not much more when I keep track of the time. So here, at least, hopefully you can see how this works for this simple data set. Again, both in this one, how I both created the grid with the scalar field command, and then I have another scalar field that's actually drawing the data. So these 2 commands are completely independent of one another. This one could actually be drawing some data, but I've left values unspecified, and I'm just using that to create these X and Y columns. And then I went ahead and calculated the Z, and I'm drawing that with the command that you see here, which notice this is a different layout. So this is what we would call a flattened layout, where I have an X, Y, and Z column specified here. Which actually, I guess I didn't necessarily need to do that. I could have used this command and specified the value in a new one. But anyway, let's go ahead and see if there's anything else here. I think that's, oh, question. Does this work with all the commands, the updating of the menus items when you drag a new group on? And yes, that does. That is a general functionality throughout DataGraph, that when you have a command with menu items, that you can just drag a new data set on and it will update all the data. In fact, you can do that not just with a single command as we have here, but you can also do that with groups of commands. If you are new to the program or haven't done this before, there's also a group icon here for grouping commands. In this case, it's not really going to be illustrating much, but if I had several commands that all used the same columns, we're overlaying different types of graphics, then I could drag and drop on the command group, and every command within that group, the menu selectors would be updated. Okay, so here's our next file where we have this data, and I wanted you to see the sort of what I'm going to create, but I'll do this also with a blank slate. So let me go ahead and actually I'll just move this back to my other screen and create a new file. And one of the things that we wanted to show you is something new that's in the beta, and it is a functionality to allow you to import data from CSV files using a URL directly into your DataGraph file. We've had, and this is also in the beta, we've had for a while this ability to bring in JSON objects, which works great for some websites, but there's so much flexibility in how JSON data is set up that it is difficult to have a general importer for that data type. So one of the things that someone was requesting the ability to bring in CSV files, and thought, well, actually the functionality that we have for JSON could be much more general and also bring in CSV files. So right now what I'm showing you is actually a website that we're going to use to grab this data that we use for this example. So I'll send this link onto the chat. Okay, and you should be, just again to check in, you should be seeing my Safari on my window now. This website is a great thing that has been put together to allow us to easily get these our data sets. And if you go onto the page that I sent you, go to HTML index, there's a searchable list here of all these different data sets. We're going to use the Volcano data set. And there's a link here for the CSV file. And so from this, you can get, I'll also send you this link as well, but just so you can see where this comes from, then here's the CSV link. And if I take this, I've got this now copied into my clipboard. I'm going to use this. If you go into DataGraph, go to the other drop-down menu, JSON group from link. We will change the name of this since it is more general at this point. But if you open this up, there is a section to paste in a URL. I can just do Command V, hit return. And what happens is the program now reads oh, it actually looks like I got the wrong data set. Let me fix that. That is not this is the Volts data set. Let me go back here and here we go. I don't know how I did that, but that's the data set that we're looking for. That looks much more appropriate. So let me do this one more time and send you that CSV link. Okay, so we're really testing this out here. See that this works. Oh, here we go. Hang on. So we will take that one away, put this one in. There we go. Works like a charm. So what is showing down below here, if you paste in this URL, it gives you a list of all of the different columns that are in this CSV file. And we will actually have it set up so you can drag the URL link from the website and just drop it in here and it will populate everything automatically. But for now, if you want to test this out, this is how you would do this. And then, and you can actually just click any one of these individual columns and then it will download it and you can see the data. And when you add them, it actually adds an object like any other column within DataGraph. But you can, and I just deleted the object. Obviously, I'm not deleting the data. It's just that link to the data. A shortcut is to go under the gear menu and you can say create missing columns. And then it just populates every column from this file into my DataGraph file. And you can see all these different columns here. Now, these R data sets almost always have a row number. I think actually they all do associated with them. We don't need that, so we can just delete it. We have our own built-in row number. So now you can see all the data that's in this, the elevations of this particular volcano. And in order to use this data within the scalar field command, I do need to flatten the data. The scalar field command, like a lot of the commands in DataGraph, it's requiring, or like the pivot command, for example, it's requiring a single column as input for the values. So I'm going to take these columns and I'm actually going to flatten them. Now to do that, because right now these are actually links to what's online, I'm going to convert these to a to number columns. So I just selected all the columns, and there's a gear menu here. I actually did this a different way last time, so we'll see if this works. Change to a number column. So that worked. That looks like that worked perfectly. Again, if you didn't quite see what I did, I just selected all the columns. This gear menu that's in the top left corner of the data table can be used to change the data type of multiple columns at the same time. So I changed all of them to a number column. When I did that, the icon here within this group also changed. It changed from being an icon that indicated it was linked to data online to just being our standard number icon. So now, anyway, I have all of my data that I have brought in, and I want to go ahead and flatten this data set. To do that, I can again just Command A, for example, will select all of my columns, and I can go under the data menu and select flatten columns. That's going to automatically append each one of these columns of data onto each other. And it's also going to then create a category column, which is showing me the name that the column had originally. And then this is the value that's going to go into the scalar field command. So a couple of things that you can do here, even before doing the scalar field, that I think are kind of useful. I can just take this column and click the histogram command and initially just get a quick look at the data. Oh, also, I sometimes forget this myself, but so handy to just click the column, hit the space bar, and then you get a quick histogram that shows you all the statistics associated with this. And let me see, I'm checking on the chat. So, okay, question. After converting to number columns, is the link to the remote CSV still functional, or am I making a copy? Right now, after converting it to number columns, it is a copy. So now it's no longer linked to the data online. If you want to relink that data or download it, I can click the gear menu again and again say, create missing columns, and now here's the linked data. So the flattened version of it is something that I'm doing within DataGraph to manipulate that data. It's not flattening the data as it is online. But again, I can recover that, and these two columns now that I created from the flattened data don't have to be in that JSON group, or it's really a CSV group now. I can drag those out and even just put those in their own group. So this would be my flat version of the data, and then not show the other ones. Right here with there's a question, what is on the x-axis, what is on the y? Since this is a histogram command, the x-axis here is just the value, and the y-axis is the count. So the next thing I'm going to do is I need to know how many, I need to create or add this in to the scalar field. And so I need to know how many grid points are on my x-axis and on my y-axis. Let me go ahead and just add a new graph and add in a scalar field command. So again, going under the command menu, add scalar field. And I'm not going to use the layout as flattened because I just have one values column here. I do have this category column, but it's not telling me the X and the Y. If you go into the, exactly, that information is not in the data. So as someone just put on the chat, you don't have the X and Y in the data set. Now, if you go to the data set itself, it will tell you that this is a 10-meter grid. So I do know the distance between each point. And because, again, in setting up the scalar field command, we recognize that a lot of data is like this, where you don't necessarily have the X and Y, but you know the pattern that the data follows. So I can go into this, the layout, and specify the layout of my data here is not flattened. It's rather this uniform row where the origin is 0, 0, and it has a particular size associated with it that is based on the data that you see here. So if I look, for example, I can see that there are, based on the rows, there's 87 in one dimension. And so I can type in that my rows are 87 rows. And then in terms of columns, I have, I can actually just look at the total number here. I have, let's see, 5,307 total entries. And if I divide that by 87, then that will give me the number of columns that I have in the data set, assuming that I did that correctly. So if you notice, I didn't even pre-calculate this, because anywhere where you place a number within DataGraph, you can also have a simple mathematical expression. So this is just the total number of rows divided by the number of rows within each column, and that should give me the number of columns. Now, I've just set this up. I haven't really done anything. The step size doesn't need to change. The step size here can stay 1, or, well, I guess maybe I could change that to 10. We'll do that in a minute. So first, I just want to specify the values. So I can, again, use the menu, or just quicker, just to click on the title bar and drag that, drop that on this menu selector, and that's it. Now I have my my data being represented as this scalar field. When I open this up, just to make it a little more interesting, I can go ahead and add a color scheme to this so that I can, it sort of pops out quite a bit more when I do that. Another couple of important things to keep in mind are, or one really important thing to keep in mind, is that right now, if I move this, it's obviously scaling with the with my change of my X and my Y. It's going to stretch the image, but because this is a grid, I want to keep my X and my Y dimensions uniform. So if I open up my axis settings, there is a checkbox here that says pad to make X and Y scales equal. And if I click that, then it's going to maintain a square grid. So then once I have that checkbox checked, then I can go ahead and change my graph here. And notice it keeps the dimensions appropriate. It keeps them scaled as in a square grid, which is the way I want this data to be. And you can vary actually whether the data is uniform row or uniform column. And for this, for this particular data, this would be the setting that we would do. So now let's add a couple of other things. I can, first of all, within the coloring section, there is a checkbox for refine. And if you check that, notice how now the entire image now is sort of smoothed out. And maybe David can comment either now or when he comes online as to exactly what's going on here. But if you change, I don't know how well you can see this online, but if you check that again, it's refining the grid in such a way that you get a much smoother image. The interpolation, there's also these interpolation menus. These are doing something slightly different and aren't going to really change this image. This is one of the things that, since this is a beta version, we're still sort of tweaking how these options will be presented. in some sense, this refinement is sort of an interpolation of these data points to give a much cleaner looking grid. Let's see, what else do I want to do here? So let me go on to the well, we've seen that you can add the grid. Let's look at, the contouring. That's what I wanted to show you. And in fact, let me swap my view here. So in case any of you are not familiar with this, this is this little swap button that's in the bottom left corner of the data table. And great, David's giving some explanation of the interpolation and how the refinement works on the chat. Okay, so if we go to the contouring and expand this out, you'll see there's a section here where one option is just a list, or I can specify what I want the contours to be. So for example, my data here, again, if I click on get my quick graph, I can get a quick view of what the range of this data is. So I could just type in 130 as a contour, or 150 as a contour. And I don't know why I'm not, I haven't checked to see them. Okay, that's right. There you go. So again, this is where you can toggle each one of these elements of the graph on and off. So now I've added contour lines at those particular locations that I've specified here within this section of the command. But I can actually do something a lot more sophisticated than that I think is pretty cool. For example, I have this histogram command, and what the histogram is doing is creating these equal divisions between the range of my data. I can change these bins, for example, and change the bin size that I have for my histogram. And like any command that is doing data analysis within DataGraph, you can extract the results of this back out into the data table. If I go onto the gear menu of the histogram command, I can extract the location of each bin, and I can also extract the value of each bin. And I don't really need to have that pop up there, but so now you can see again, the bin location, the count of how many are in that particular bin, and I can use this bin location to populate my contour lines. And so we'll go ahead and just select that. And now you can see a lot of contour lines because my bin in my histogram is relatively small. So if I go back here and change this bin size to a bigger number, then my number of contour lines is also going to change. And what I probably do, because I do this all the time, I probably create a global slider to make it easier for me to adjust that while I'm paying attention to my actual scalar field here. So if I wanted to create a slider, for example, that uses, that is changing the bin on the histogram, let me go back to this. And maybe, well, maybe this is from, I don't know, 1 to 20, say, for example. So now I've made a slider that has a range. Maybe I want this just to be integers. I don't know, it doesn't necessarily have to go in between. And this would be my bin slider. So now I have this global variable called bin that I can place within my histogram command to change the bin size. But now as I change that slider, it will again also change the contour lines within my scalar field, or just type in a specific value that I want the contour lines to vary by. What we don't have in the version right now is labels on each of the contour lines to show what the numerical value of each one is. This is something that we are planning to add, so that you will be able to have a numerical value that shows on the contour line so you can see what it is. But even without that, I think this is really a very, a really easy way to generate these types of graphs. The one thing I just wanted to point out to you before I would like to turn this over for David to do another example is how do you show the color scale? Actually, the question has just popped up on the chat, so we're definitely of the like-minded right now. So when I go under the command menu, there is a command called the color ramp legend. This can show the color ramp that's built into the scalar field. It can also show a custom color ramp if you've created your own color ramp with colors that you're interested in. So when you add the color ramp legend, initially I'm not really seeing anything, but I can pick the command to show the color ramp here on the left-hand side. And I have an option of, if I wanted my color ramp here to be a little bit smaller, then I can change on the scale how big this color ramp is. And there's some options for where I show this. I don't want to get too much into this because I want to make sure we get through again to the next example. Okay, so one question, I assume that from the name that the contouring relies on an evenly spaced grid. Is it possible or planned to allow contouring on a non-regular X and Y values? I think that the contouring will work on, well, let me take that back. If you're thinking about, all of these examples are on a regular grid, in that you don't have unevenly spaced points. I'm not sure if I'm saying that right, but if you, one thing, actually, I think what I'll do right now is, so I think we've done enough of this example. And I'll show you, if you go to, actually I can do it from here. If you go to the scalar field command, click on the gear menu and go to the help for the scalar field. That's going to bring up the knowledge base article for the scalar field, where it gives a little bit of information. So it tells you the different grid types that are possible. And then there are a number of different examples here. And for each one of these examples, there is a file that you can download. These aren't on the example files because since they're just beta versions, or since it's only in the beta, we didn't want to have this be on the example file. But these files, I think, are all somewhat fairly annotated. You can see this one has a non-uniform, it's a rectilinear grid, but that's sort of kind of an interesting look. You have random fields that you can do. Here's the same data set that we were just playing with, that you can download that file. You can do logarithmic data, logarithmic distribution. This is a microarray data set that we found, that we went ahead and did this. And I think this is actually sort of interesting because here your y-axis is categorical. It's not showing you a numerical, I mean, this is plotted on a numerical grid, but we're showing categorical values on the y-axis. So the scalar field is pretty flexible in being able to use not just numerical data, but also categorical data. And this last one is I called it trippy because I think all these shapes are pretty interesting. So these are all created using the scalar field. And David, are you ready to do an example? Because he's going to kind of walk you through something that's using these mapping techniques to create different shapes using the scalar field.
I think I am. You just have to enable screen sharing for me.
Absolutely. Okay.
This is the trippy file, and I also have a little bit of another simpler data file to sort of show this. Let me see, there it is, scalar field demo. So let me very quickly kind of show you how this is on a simple example. And the simple example here is that first do the same thing as she said, is that you make one scalar field that is sort of not going to be drawn, but it's going to be laying out that grid. So the grid is an n dimension here, and this is a 10 by 10 or 11 by 11. You can sort of see how if the grid changes, it becomes kind of coarser in here, right? So this is a fairly coarse grid, right? 8 by 8 grid here. And you can see if I draw the grid values, is that not? Okay. Anyway, maybe that this is beta, so not all the combinations seem to work, and that's one of them. But
David, can you make that that file full screen?
Or it's bigger.
Yeah.
So let me just work in a big. Well, I kind of want this for ratio for the.
Yeah, that's good.
Resize it.
Yeah, thank you.
And the data doesn't matter really, so that we're going to swap that out to sort of see this better. And so this is a 10 by 10 grid or 11 by 11 technically, of n is 8. Then this is a 9 by 9 grid with a step size coming from here. Step size 1 over n. Grid size n plus 1 by n plus 1. So this will be a 0 to 1 grid unit. Right, so here's what do I hide the den block? Right.
There you go.
So now what this is then pulled back into the x and y coordinates. Like you can see that this x and this y is coming back from that command here, and then I take the x in here, I compute a value based on this x and y, just sort of as a little, I can do x, y squared to sort of change the coloring a little bit, or sine of x, like 5x times cosine of 6y, to kind of change it up a little bit. And this is the value at each grid point. Now, what I want, if I draw this, here's the value on the x, and then replace this with the x and the y, I get the value back, because it really is kind of reconstituting what this guy here laid out. Because the uniform row is also by rows rather than by columns. But what I want to do here is that I take to set up the trippy example, is that I then map those columns here. So U and V are mapped versions of the x and y coordinates. By mapping it this way with cosine and sine, you do a simple rotation with an angle theta, right? And the angle theta is another column, which is just the angle that I've specified here as a entry times the y coordinate. This is a little bit of an odd thing, which is that it rotates each point with an angle around the origin, but the angle will change as you go up in the grid. So what is the effect of this? If I change this into the U and V, and I look at this as arrays, I really have a mesh, or a sort of, it's in a, by using the first row and the dimensions, it knows how to take that column and reconstitute a block, like a rectangular block of numbers. And it will do that to the value as well as the U and V lists, because I set the type to be arrays. if I had different, if my x coordinates were non-uniform, but sort of they're always the same for every x coordinate and always the same for every y coordinate, I could have two lists. Then the list would not be blocked, it would just be the coordinates in the x and y direction. And here, if I have a u and v coming from this kind of unflattened or sort of collapsed into an array, here I can then vary the angle and this will rotate it, do that mapping. So every point in the original is being mapped. And if I option drag this, for example, and change it back into the X and the Y, this is the original shape, right? And that's the original shape of that. But if you take the angle, then it sort of rotates each pixel in it because the X, Y coordinates are mapped into UV coordinate, and then that gets mapped out. Now, if you go into the trippy file, this is the trippy file. This is done in various different kind of cute applications of it. And if you open this up, you can see that there's built here individual entries, and they're all basically the same thing. Is that there's a Z, which is this thing here, can either be Z1 or Z2, different values of computing the Z. The location is U and V, and it's either in the circle group or in here, it's in the, this is the underlying thing, or in the twist group. And they're all different examples.
Is that the square? The square group has annotations, I think, in it, or some explanation?
The square group has more annotations, or like, how did you create this? How did you, basically what Pamela went through in terms of how did you extract the columns out? And then this one here is the actual command, and that is the Z, and just the X from the unrotated. This is the X that comes from the output, from the sacrificial command, which is this guy here, and this is the Y coming from this guy here, which comes from this one here. But in right that's
yeah.
Right? And here, this one here is where the grid is visible. So if you look at that, the grid is underneath here. This like lays out the grid of that. But the interesting thing here is we set up all kinds of things to kind of be dynamically changing. So the T argument is being used inside here's a 100T that makes this kind of phase being shifted by 100 times T. And you can see how that is changing in every one of these. And then that kind of, right? And you can sort of see that when this is, so what is happening is that this is what would be called a logically rectangular grid, because logically your X and Y form a two-dimensional array of coordinates. And every pixel, instead of being just a square pixel, is now defined by the corners of that, the corresponding X, Y locations. So, but it's still kind of logically a rectangular grid. It's not an unstructured grid, which would be triangular, but this is logically rectangular. And it maps, even if you can set this to be logarithmic, right? Wait, oh, this of course is not logarithmic. This, any of these, like this one here, you can switch the axis to be logarithmic, and that makes things even more interesting, because then it maps the X coordinates onto a logarithmic axis in the X-axis. So if you draw the Y numbers, you can sort of see that that's a logarithmic scale going into it.
It's amazing how that looks like just a flat surface.
Yeah, like the brain tries to see a 3D shape out of it, of course. So you think that this is like a pillow top, right?
Yeah.
At least I do. Here I had, I mean, how am I doing in time? I have a little bit of time, but I want to show you back into this. when I had this example, and this is kind of one question that I answered about the like if you have non-uniform grid points, you have a sample of XY points that are not on a grid and you want to draw them using a scalar field. And the standard thing is to interpolate them or weigh them onto a uniform grid, which then can be drawn as a bitmap. And certainly that is something that we're planning on incorporating as an option here into DataGraph at some point, which is the layout rather than being like row first, column first, flattened. It would be non-uniform. And then the X and the Y and the value, which is always there. There's an X coordinate, what is that? Y coordinate, what is that? And the value, what is that? That would be the X and the Y and the value would be kind of flattened, but not on a grid space. It would just be the spatial location. And then you would have to specify where you want to interpolate them on, right? Yeah, I think that's what we have in mind. If you have something else in mind, let's give us feedback on that, because that's the whole point of keeping the scalar field in the beta, is that we want to kind of get feedback and feature requests fairly early, before it comes out. Now, here's something that I want to kind of show a little bit interest, sort of, maybe this will help, but hopefully it will help a little bit with how this is structured and how you can draw your own data set into it. And also I'm going to show a little bit of a hook into ImageTank, because just as a bonus. And what I did here was that I took, and this is ImageTank window in here. I have a URL request here that picks the ImageTank icon from the website. This is a URL fetch of a PNG file. That PNG file is then read in as a bitmap, made into a grayscale field, and then flattened into a table. So you can sort of see here that this is the same thing. It's sort of done by row as well. It's that's the X values are repeated. Like first you see the Y is equal to 0. So that's the first line of the bottom line. And the X values are 0 up to, well, this is a 100 by 100 grid. So this will be a 0 up to 99. And then again, for Y is equal to 1, it will be 0 to 99. And that will be 10,000 because it's 100 by 100 total number of pixels. Now, the interesting thing here is that that is then saved into a DT bin file. And this is the same mechanism as DataGraph uses to interact with R. It's just a DT bin file is a file that it can connect to live. So if you go back into here, the transfer here is that it opens that same file, and similarly to the CSV file that is connecting live to a CSV file stored online, this is connected live to a DT bin file stored on your disk. And then this is extracting out the table coming from there, the X and the Y table, and the value table. Here's the X and Y, and the gray. These are the fields that are in here. These are, and if you look at it over here, that's the X and the Y, and the gray are columns. This is a 2D point column and is ignored because DataGraph does not have a 2D point column in it. But then you have.
So David, can you change can you change the image in ImageTank, and then you would see that in DataGraph?
Yeah, I'll show you that. So here's the X and the Y, and the same thing. Now there's in between, there's the theta column and the Y, and the same expression as before, because the values are X and Y, just same angle function, same mapping. But I need to map it into 0 to 1, so I'm dividing by actually I should divide by the dimension. Right, so I need to do that also for the dimension here. Oh. should technically be dimensioned by 1, but dimension by -1, but it doesn't really matter. So and then the same thing here is if you change the angle, that, and here is the rotated version of that, and this one will skew that out, right? So here is the angle from 0 to 2 pi. You can sort of see that 0 to pi as you rotate this shape here, right? So it's the same thing. It's instead of having this artificial sort of image that I have over here, that certainly I could sort of make a little bit more refined, but it's just still kind of an analytical expression. This looks more like the data. So this is the raw data itself, just taking the gray X and Y to reconstitute it from what the flattened version is. Because essentially what ImageTank did is that they looked at this as an array of numbers, similarly to the array that you got from R in the beginning, and flattens that for you into a table. But if the array changes, this will flatten automatically for it. So the simplest way of doing this, and I'm going to see to demo this, is that if you go in here, I'm going to this window is not going to overlap here, that there's two URLs. There's the ImageTank icon, there's the DataGraph icon, and I can switch from the ImageTank to the DataGraph. And this needs the different dimension. This is that here is because it needs to know the dimension. And 100 by 100 is not the right dimension. And because it doesn't match, there's a red dot here. If you click on the dot saying like length of the X column is incorrect, is kind of indicating that that's the problem with this. So that's dim by dim. And now I have that done here. And if you change it in here, it changes in here. And what is happening here is that this export here is constantly saving. Whenever I change this, it resaves the file, and then this DataGraph notices that the file did change because this link is live. It's not easy you can't see if the web link modified because you don't have a notification from the website, but the DataGraph monitors the file location, and when it notices that the file was overwritten, and that happened when I switched from here to here, it reloads it and reincorporates everything based on that.
That's cool.
So
yeah, we're right at noon, and what we've been doing at this point is just sort of acknowledging some people may need to head out. We hit our 60 minutes, and I think we pretty much covered what we really wanted to cover to give you an overview of the scalar field and to hopefully whet your appetite a little bit to try it out. And again, this is the perfect time to give us feedback and to help us to see if there's any bugs in there before we release this, so that we can get it out. We've had a number of people use it, and so I know it's being used out there, but definitely more is better.